Okay. Is it recording? Oh. Okay, I like this first quote. It says life isn't equal, but it is fair. Everybody says life's not fair. Well, guess what? Life is fair. The problem is it's not equal. Not everybody gets the same exact experience out of life. Never will. Never has. Okay? But we all have the opportunity to be the best person we can be. We have opportunities to do this. We just got to take them. So life is fair. You're given the same opportunities, but it's not equal. It's how you take those opportunities. Okay? So, we learned in Unit 1 that solving equations was Unit 1. Okay? Understand that? So, for this unit, we're going to use all those skills we learned in Unit 1, but there's going to be one exception. One critical exception. Okay? When we multiply or divide by a negative number, the inequality sign has to switch places. Has to switch, okay? So, grab a pencil real quick and underline those critical parts. Okay? If we multiply or divide by a negative number, okay, we must flip the inequality sign. That's critical. Okay? Why does that happen that way? Okay? Well, it's just kind of the way the nature of numbers works. Let me show you what I mean. Okay? Is that true? Is 6 less than 8? Okay, that's true then. Everybody agree with that? Okay, if I divide both sides by negative 2, okay, this becomes a negative 3 over here. This becomes a negative 4. Which one's bigger now? The negative 3 is. So because we go to the negative side, then the signs flip, and because the way the number line works, the negative side, the numbers are kind of backwards, and so they're smaller going that way. So this forces us to change that sign. Now the problem is you're going to have something like this. You're not going to see a number there. You're going to see a variable there. And so when you divide by negative 3, you got to remember that you have to, negative 3, you have to make sure you flip that sign to account for that negative change, because you will not have a number there to compare it with. So you've got to remember to flip that sign, get those alarms going. Every time you see it divide by a negative, you have this alarms going off, all things flashing, lights going, your siren screaming. You're dividing by a negative, so flip your sign around. Okay, that's critical to this equation solving. All right. Okay, so we're going to do that in a minute. We're going to go through some basic stuff first. Okay, here's our symbols. Greater than, less than, or equal to. We've done equal to. Now we're doing greater than, less than. Okay? But there's always these three, what they call the trichotomy of numbers. Okay? That when we compare two numbers together, these three things, one of these three things has to happen. Okay? What do you need? What do you need? Okay? What do you need to write notes down with? Have you got a pencil? Okay, the trichotomy of numbers means this. Okay, one of these, if you take two numbers and compare them, one of these three things has to be true. Okay, either two numbers will be equal to each other, one number will be larger than the second number, or the first number will be smaller than the second number. One of these three things has to be true. Now, if we come along and say this, I do greater than, but I put a line through it, this means not greater than. Okay? Alright? It means not greater than. Well, if it's not greater than, then my two choices are simply, if I can't use this, then I've got to use less than or equal to. And that's where these come from. This less than or equal to means the exact same thing. Okay? So less than or equal to is the exact same thing as not greater than. These two things are the exact same value, same condition. Okay? And that's where these come from, by you saying, hey, I can't use a not greater than, so I use less than or equal to. And this is two different freezes. It's less than or equal to. Cannot be both at the same time. Okay, it can be the less than it, or it can be equal to it. Cannot be both. That's what the or stands for. The conjunction or means one condition or the other one, not both. Okay? Alright? Okay. So, that's where these four symbols come from. Greater than, less than, greater than, equal to, or less equal to. Now, on Alex, when you put your mouse on the top of these, if you get which one's which, if you let your mouse hover over these, it will tell you which one it is. Okay, so you can kind of remember what it looks like. Alright? Okay. And then we have these words that kind of help us, that mean the same thing as greater than. So more than or exceedingly or above, something like that. Okay? Fewer than, below, means less than. These words mean the same as greater than or equal to. We're going to use those. Now, of course, this is the one that you're working with right now is your lifetime. At least, because right now you must be at least 15 years old to obtain a learner's permit. Okay? What does that mean? Can you be 14 years old? Got to be at least 15, right? Can you get it on your birthday? The day you turn 15, can you get a learner's permit? Can you get it when you're 25? Okay, so you have to be exactly 15, or can you be 15 or more? Yeah, okay, that's what it means. Okay, you kind of experienced one like that a little while ago. Okay, Mr. Langston said that review, okay, must be greater than or equal to 80%. If it's not there, you don't take a test. So inequalities show up in real life all over the place. Okay? All right, let's do this first one. Okay, we're trying to find out if this is a solution to this equation or not. All right? So the equation says we're looking for a solution. Solution means it must satisfy the equation to be true. Okay? And our equation says v is greater than 8. So we put a number in for v, it's got to be greater than 8. And they give me some values for v over here. So let's find out. Let's put them in and see what happens. Is 11 greater than 8? Okay, that's pretty simple. Is 15 greater than 8? Okay, notice if I put those in there, they're pretty simple to see if it works or not. Is 8 greater than 8? So if you get lost on doing these, you can't do them in your head, write them down. Because writing them down lets you see what's going on. Is 5 greater than 8? No. Okay, I'm going to give you another number then. What if I do this? If I say 11 is less than or equal to v, and I make a new chart over here. Okay? Let's answer this question. Okay? Is 11, if I use this 11 again here, I put it where the v is. Now this is backwards, and it's kind of hard to read backwards, so if I get lost, just put numbers in. Is 11 less than or equal to 11? Equal to, right? So that works. So I can put yes. Is 11 less than or equal to 15? 11 less than 15? Yeah. Why did somebody say no then? Okay. Is 11 less than or equal to 8? No, that one's no. Okay? Well, the problem is, guys, they're written backwards. And so writing them backwards kind of makes them really hard to understand. The best thing to do, Ren, is don't use them backwards. 11 is less than 5? No. Take this number right here and flip it around. Don't do them backwards. Okay? So if I flip this around, I put my v on this side over here. The opening is towards the v, so make sure my opening is towards the v on this one. And throw your 11 in there. And then it makes more sense to read it this way. Okay? So if you're having trouble reading them, either one, put the numbers in and look at them carefully, or turn it around. Make sure you just turn it around. It makes it easy to turn around. Okay? If we're graphing them, we're always going to turn them around. Okay? And I'll show you why in just a second. Alright, let's go down here and do numbers 3, 4, and 5, or 2, 3, and 4. Okay, we're going to translate these inequalities into equality statements, okay? we're looking for the same thing. We're looking for those key words. Okay, to help us out. All right, first one, number x. That's a variable. Anytime you see the word a number, the word's a number, that means we're looking for a variable right there. So this means variable. Okay, what does increase by mean? Okay, means add. Thank you. We're adding 7. And then it says is greater than. Well, that just means greater than, like that. So now I can write my statement. The number x increased by 7 is greater than negative 11. And again, the more you practice those, the better off you'll be. Okay? All right. Number 3 says the old car can go no more than 70 miles an hour. Okay, so they want to find a variable. The old car says use S. So my old car is going to be the S variable. And it says goes no more than 70. What does no more than mean? Okay, if you're having trouble figuring it out, here's a little trick. Go over here and go, well, I could be equal to, greater than, or less than. Throw all 3 of those out there. Then throw out the one you can't use. It says I can't use no more than. So I can't use more than, so throw that out. What's left over? Less than or equal to. So this means less than or equal to. So now I can write my inequality. S is less than or equal to 70. And all we're trying to do on these is get you used to hearing the terminology of greater than or less than. Okay? All right, number 4. Temperature in St. George at 5 p.m. is more than 100 degrees Fahrenheit. Okay, we got T for temperature. Okay, we have the is more than. What does more than mean? Sylvia, what does more than mean? Huh? Greater than? Okay. So that means we're ready to go. We got T is greater than 100. Okay, any question on these 3? Again, practice will make you better at these. Okay? And if you get lost in your terminology, just ask a question. We'll help you out. We'll talk you through it. Okay? Okay. All right, number 6. Okay, we're going to graph this inequality. Okay, so when we graph, we have 2 things that we look at. Okay? First one, we have open circle graphs. Open circle graphs when we cannot be equal to it. These include symbols of greater than, less than, or not equal to. Okay, the other symbol we use is we use closed circle graphs. Closed circle graphs have the circle colored in. Okay, these are when we can be equal to, and these include greater than or equal to, less than or equal to, or equal to. Okay, 2 differences there. Now, when we graph equations, we always want the variable on the left. If the variable is not on the left-hand side, move it there. Okay, the reason we want the variable on the left is because when the variable is on the left-hand side, this symbol points the way I want my direction of the arrow to go. So if that's pointing left, I want my arrow to go left. If it's pointing right, I want my arrow to go right. And if you put the variable on the left-hand side, it always points which way you want it to go, so you don't get confused. Okay? So when you graph here, first thing you do is you look at your inequality, you find the number you got to go to. So we're going to go to negative 3. Find that on your lead number chart, right down there. Okay? Then look at your symbol. Okay, is your symbol going to be an open or a closed circle? Got an equal sign on it, so it's got to be closed, right? So go to -3 and put a closed circle at -3. Okay? Then your arrow says go left. So go less than that. So from that arrow, go left. We have our graph. Okay? Are we okay with that? Like I say, but if you always put that variable on the left-hand side, if it looks like this, it means the exact same thing, but it's just hard to graph that way. So don't graph this way. Turn it around. Okay? Make sure to graph with the B on the other side. Alright? Alright, next page. Number 6. Okay, now we get to take it off the graph. Well, that's easy. Okay? We just do it in 4 real quick steps. Okay? So the first step, find our variable. Okay, if they give you one, use the variable they give you. If they don't give you one, make up your own. Doesn't matter. Okay? But they give us the variable x. So we're going to give us the x right here. You get your variable started. Start with your variable all the time. Step 2, see where your line goes. Does it go left or right? Boy, I can't get that on the graph. Okay? Alright, so find my line. My line's going right here. It's going left. So because the line's going left, I make the arrow here point left. Okay? And then I check my dot. See if it's open or closed. Okay? This dot is open. That means there's no equal sign underneath here. Okay? Last thing I do, check my number. That's at 5, so I put a 5 right there. I'm done. Okay? Alright, so 4 quick steps. Grab your variable, check your line, check your dot, get the number on there. Okay. Alright. Any questions on that? Okay, number 7. Compound means more than one. Okay? I've done the equation. I've done a lot of inequalities that have compound inequalities that have 2. I've done some that have 3. I've done some that have like 10 or 11 different conditions. Okay, so there's different sets you got to look at. There's 2 things we look at, 2 conjunctions. The converse conjunction is or. Okay, or means at least one condition. Okay? So I can satisfy one or the other. It doesn't have to do both. So what these graphs end up looking like, okay, is the graphs are usually are split graphs. They go 2 different directions. Okay? Whether they're open or closed doesn't matter, but they go 2 different directions. And so you can satisfy this condition, or you can satisfy this condition, but you can't satisfy both at the same time. That's why it's OR graph. They're always split up like that. Okay? The AND graphs is all conditions must be satisfied. Okay? AED. Okay? Meaning that when I do this one, okay, these graphs are normally overlapping graphs. Okay? So our graph goes like this, and we'll have a graph between the 2 lines. Because those numbers in between there are bigger than this number, let's say 0, but they're also less than 5. So these numbers are bigger than 0, and they're less than 5. And so these are overlapping graphs. Okay? Because you can satisfy both at the same time inside there. So, when we graph these, the very first thing we got to decide is this OR. So this is OR graph. We expect this to look like this when we get done. Okay? So we go down here and we graph these separately. Okay? So the very first thing I do, again, is go to my number. And I like to do it in pencil first to get my, where'd my pencil go? There it is. Okay? I kind of like to draw a little map with my pencil first. So I find my 2. I put it over here. It's an open circle at 2. And the arrow says it's going to go down. Okay? Then I do my second one. I have a closed circle at 5. So I go to 5 and I find me a closed circle. And this arrow goes to right. So this is definitely an OR graph. They're separating. So then I'll get and do my final graph at the end. So I have an open circle at 2. And as we get into deeper compound inequalities later on in the lessons, like I think it's lesson 3, is you'll see why we do this graphing, why I do that mapping before I do my graph. Okay, because it can get real confusing real quick. Okay? All right. You gotta wait a minute. I'm not done yet. Almost done. Okay? Okay. So now we're going to take these back off. So we're going to do the same thing we did up here on number 6, except we're going to add one more thing. We got to add one more thing up here. Is it an AND graph or is it an OR graph? When you do compounds, then you do everything else the same. So look at this graph. This is an AND or an OR graph right here. That's an OR graph. So we'll throw the word OR right here, right in the middle. Okay? Then just do the next step. So the first step is get your variable. They said use the X first. So grab your variable. Put it over here. Okay? We're doing the bottom one. So this line goes to the left. So make your arrow go left. This line has a colored in circle. So this needs an equal sign right here. So put an equal sign underneath your sign. And then your number is at 2. Okay? That's the first one. Second one, start with your variable again, X. Arrow goes to the right, so make it go to the right. There's circle is open, so no equal sign needed here. And my number is at 6. Okay? Questions on that? Okay, now comes the fun part. We're going to solve equations here next. Okay? So what was that rule again? We talked about solving equations. What's that thing you got to watch out for? You got to watch out for multiplying and dividing by negative numbers. Okay, we got to be careful on that. That's a big clue. Okay? So here we go. Same principles. We do them the same exact way. So, step 1, find the equal sign, draw the line. Don't have an equal sign. Have an inequality sign this time. So find the inequality sign, draw the line. Step 2, find the variable I'm solving for. This will be the exact same we did before. So find the variable I'm solving for, leave that alone, get rid of the negative 10. So we do an add 10 right there, do an add 10 right there. I did not multiply divide by a negative, so this does not change sides. Leave that going the same way. This 10 goes away, have a y right here, negative 4 and 10 is 6. Okay, I'm done. Now, when you type the answer in, you can type it exactly like you see it. 6 is less than or equal to y. Type it just like that. You want to flip it around? Go ahead and flip it around. Put the y first, but make sure you turn this thing around so it points the proper way, so it matches up the other one. Okay? All right. Second one. Here we go again. Find the inequality sign, draw the line. Find the variable I'm solving for. Okay? Get rid of this negative 3. This negative 3 is being multiplied by. So I divide by negative 3. The minute I do that, my alarm went off. Did you hear my alarm go off? The lights flashed. The arrows jumped out here and said, hey, that's a negative number. If I divide by a negative number, this needs to turn directions around. Okay? So now I got these 3's go away. Get the W on this side. 24 divided by negative 3 is negative 8. I'm done. Okay, now, pay close attention to this last one, because this one's going to be kind of tricky, okay? So you're going to see it comes on your assignment. Alright, the first thing I want to do with this, and it's okay, as okay, really don't like that fraction. Okay, so my first job, I don't care about the variable right now, I want to get that fraction out of there. So the first thing I do is I eliminate fractions. Okay, because I really don't like fractions. Right? How do we do that? It's real simple. See this 9 over here? You're going to times by it. Anytime you have a number on the bottom, just times by that number, it'll go away. But here's the problem. That negative sign, you gotta learn to trust these negative signs. On a fraction, that negative sign, it doesn't matter where it goes. Right now it's out front. But if I want it up top, all you do is shove it up top. It means the exact same thing. Said negative 7/9 is the same thing as negative 7 divided by 9. Still a negative 7/9. And if I want it on the bottom, I just shove it down to the bottom. Because 7 divided by negative 9 is still a negative 7/9. So those negative signs on fractions, they can float up and down. It doesn't matter where you put them. Okay? Because it always equals a negative number. So what I'm going to do is, because I have lots of negative signs here, I'm going to get those negative signs first, gentlemen. Okay? So what I'm going to do is I'm going to put this negative sign down at the bottom by making that positive, making that negative right down there. Then I'm going to times both sides by a negative 9. Times by negative 9, we'll get that negative sign and the 9 to go away. But my alarm went off. Did you hear my alarm go off? See the flashing lights? Okay? I'm timesing by a negative number. So this has to turn around. Okay? So these 9s now go away. I have 7u right here is greater than positive 72. Because negative 8 times negative 9 is positive 72. Now I'm going to get my variable alone. My fraction's gone now. Now I'll get the variable alone. Okay? Go back to my variable. Divide both sides by 7. I'm dividing by a positive number, so I don't worry about changing my sign. Okay? 7s are 1. This becomes u is greater than. This will not divide evenly, so leave it alone. Okay? Reduce it if possible. That one will not reduce because 7's a prime number. So that one's stuck. Okay? I'm done. Okay? Questions? Those fractions are going to be a little troublesome for you, so just be careful on them, okay? But get rid of them as fast as you can. Okay, I'm done. You got an assignment on 2.1 on Alex. Go get 2.1 done. Okay?